First, we'll go to the OpenLane website, and then now you can follow the steps. First, we need to get the Docker first. And actually, getting a Docker engine is enough. And first, we'll create a repository. And then we'll install the Docker package. And I'll just simply run the testing. Yes, and Docker is now good enough. But we still need to manage the Docker as a non-root user. Otherwise, we will need to Otherwise, we will need to input the sudo every time, and that's not really how it works. And then simply and just add user, user. And let's try to run it without sudo. The permission denied. That means we're still not creating. Great. And then we can run the Docker by our without sudo. And then we can just go to the OpenLane, get to the OpenLane GitHub, and just clone the OpenLane. And also, we will also need to install the Python. Okay. Let's see. Also this. And also we'll need to install the Git also. We'll have our Git. Oh, and also we need to install the make. Now we'll go to the OpenLane directory. We can run the make. Okay, the error is due to the version of the PDK. Um, um, Actually, we'll have to go to the CIEL. To go to the CIEL, we'll have to go to it. Go to the environment first. Let me check. Uh, got source B, and B. Now we'll get into the virtual environment, and after that, we can check the CIL version. Yes, this is installed. Help check the function, and we can see that there's a ls remote. ls remote pdk sky one this 130 and those are the versions of the uh, different PDK versions. And then we'll choose this one. Then we can exit the virtual environment. And then we can look at the OpenLane. And then open the make file. And in here, you can see many configurations. But we just go to the PDK here. Okay. And then go to insert mode. These are version, number, and then right click. And then we can make the PDK. Let's see. Maybe there's something wrong. Ah, I just missed something. I have to specify. It is Sky 130, Sky 130. That should be all right. Yeah. And we're downloading the PDK. Oh, the PDK is the process design kit. Also, then we can run the make. There's the error. Permission denied. Ah, uh, mainly due to the uh, settings of the Docker. So make. Alright. After that, we can do the make test, which is the official testing example in OpenLane. And now we're running the OpenLane flow. And remember that we have to configure the Docker carefully. We need to configure it by adding the new group, adding our user in the new group instead of using the root user because it might be quite complicated to use the root user in the further usage, especially when we need to edit some files. If we use the root user to do the make, and then we need to use the root user to open the file, which is really uh, really annoying. And we can check the results. We'll go to the design directory, and you can see our SPM example, SPM, and we can go to the runs, and here is the opening test. And you can see that there are so many stuff in here. And to see the results, we can simply go to the results. And you can see there's we can go to the final, and our GDS file will be located in here. And you can see there's a GDS. Yeah, and you see this spm.gds file. And here's our GDS file. And we can copy our path first. And we can go back to the OpenLane. Oops. And we can use the K layout in the, we need to install K layout first. Zero, install K layout in order to see the GS file. I mean to visualize the GDS file. And then we can use the K layout and copy our directory to here. And then remember we will choose our GDS file, GDS, and oh, I believe we can try it again. or we can just go into using the file system, go into sign SVN and runs, and I guess results, final, go to DS, open with KLayout, and that's it. And there's our layout of the GDS, and it is an example provided by the OpenLane official. And for if you want to start a new project in here, actually you need to go to the designs and you need to make a new directory. For example, new design, new D, and then you need to go to the new design, and then um, you have to make a new directory called source. And you can see that there's a source, and go back to the OpenLane. And then run the make mount. Make mount is to enter the uh, into the container, and then we can run the dot load.tcl file. But yeah, design our design name new and then back to the initial new design config add to design config file .tcl to do the configuration. And now we go to the design and go to our UD and well, we got some problem, but it's okay. Yeah, easy out. Design maybe design config. Oh, Let me check this one. Yeah, and now we have the config TCL. Yeah, we have a config TCL file, which means our configuration is success. And then we can create a new file inside the source. Mm, For example, the module new laptop. No, wait. And actually, I can include the source file. That's fine. Maybe we can just create a new source file now. Module. Oh, um, for example, we can just create some simple stuff. Uh, a simple adder. Then we can do the assign results equals to A plus B and module. And we should combine. But then we can do the. Oh, okay. We have to edit the. I forgot to edit the config file. This config.tcl. Actually, you need to edit this design name to a top module name. And for my top module is the top. So I just simply like this, edit this, close, and then you can run the .flow.tcl, .tcl, and our design name will be, wait, I missed something. Design. And there should be all right. Okay. We can see that there's two error found by the linter. And to check this, we can simply go to the OpenLane designs, UD runs, run files, take the log services, and we can see the linter log. Okay. We missed a syntax, so we can just go back to the syntax and run it again. Oh yes, we missed the syntax here. Then just save it, and we can go back to run it again. Okay, so the failure is because of this. Yeah, the core area is too small for the power grid settings. And actually, it should be fine for some big uh, designs, but for such that small example design, it will have some errors because the core area is too small. For example, I just designed a adder circuit. I just perform a simple adder circuit, but that's not enough. And actually, we can search some testing program log example. Okay, we can get uh some greater scale design code. Um, for example, we can just choose this, generate by the AI to run as an example. The design UD source copy, and we can edit it, paste it, and edit the top module name to the top. Let me try it again. Okay, still too small. Let me check if there's any solution. Because our design is too small. Actually, we can use the SPM's resource to do the to do as an example. For example, we can edit this. Then this file copy. Computer basic, and we can run it again. Because it's just an example, so I just copy the example, visual example program test to finish the test for testing. But for real design, for example, for um, larger design, I mean CPU design, or some module design, there's yeah, you won't have the problem of the current area, core area is too small. The current core area is too small. It's just because of uh, the design is too small to run. Because OpenLane flow is an ASIC flow for a really small design, such as some basic component, adder, decoder, um, it doesn't work. We need to edit the power grid settings, and could be quite complicated for the beginners. And I think for most people, it is not necessary to edit the power grid settings. So I will not do here. And let's run the game. Okay, this error again. Oh, see, because of the top margin, it's still the top. That should be fine. That should be fine now. Yeah, and you can see we successfully passed the step 6. And passing the thing. It might take some time to do the synthesis and the full flow because it not only do the synthesis only, it only do the routing, um, the layout, and actually it is all the ASIC flow from the RTL to the GDSII file. Okay, now our flow is completed. It's really sorry that I forgot to record. I forgot to put the mic down, so there might be some sound hasn't been recorded. I just talk it again. What I have done is I create a new design. I create a new design called the OpenLane designs called new D, and then I create the source file, and also I do the config.tcl, and then in the source file I just simply copy the official testing program here, and then do the testing, do the run of the OpenLane, and you can see the success flow complete. And we can use the K layout to open the computer file. OpenLane designs, need the runs. Our latest run is here. You can see that. And results, final, GPS, and this one. Select the open with K layout. Yes, here's the layout. See that? The circuit, the floor planning. And actually we can see lots of other stuff in here. For example, this is CPS, visual routing file, and actually we can see some reports in here. The synthesis report, CPS report, If I'm not remember wrong, there's something we can see all of the what? Let's see. See this? Let's see. Yes. Oh yes, the manufacturer update this one. Yeah, and you can see our DRC summary. We have zero DRC violation, and the LPS is LPS clean. There's a summary of our design. The DRC is design rechecking, and the LPS are the LPS is the layout versus schematic, and it is also correct, which is good. And now that's the end of the OpenLane initial tutorial. And actually, the OpenLane you can configure many other stuff, and I will include it in another video in the future. As this video is just teaching for the beginners how to begin with the OpenLane from installation, from configuration, from simple configuration. And now that's the end. Thanks for your watching.